saying these three angles here, 65 plus X plus 44, they add up to 180 because it's a the straight line. There we go, form a straight line. So the value of X must be 180 minus 65 minus 44. I got 70, 71 for that.
Okay.
I don't know how it's going to try that. Now move all three vertices of the triangle above with your mouse. I really don't understand what I'm, okay. Okay, so they're trying to show you how the angles are changing. See how they were 66 and 66,
Mm-hmm.
and now they're 77 and 77.
Yeah.
And they're I guess they're just trying to get you to see that these relationships hold.
Mm-hmm.
After moving the vertices, the new value of X is it's still so you see the three angles still add up to 180. So we still have to take 180, subtract 101, subtract 36. I'm not sure why. This must be interactive. So if you take 101 and 136 and subtract from 180, you get a new angle. All right. So we got to do a bunch more of these. Okay. Wow. All right. Well. Okay. New problem. Okay. So like what you're trying to, I think what they're trying to get you to do each time is recognize that this angle here, this 66 is the same as this angle down here. And this 61 is the same as this angle over here. Like they look really, really similar each time is what, so MNO, so this 66 degrees is congruent to NMP. So this one down here, and it's again because they are alternate interior angles. So you should see this pizza slice come down here, and there it is. Now angle NOM, N-O-M, okay, that's the same as angle QMO. So that pizza slice is going to come down here. The order could be different. It could be OMQ. The order of the letters doesn't matter as long as M is in the middle. And that's again because of alternate interior angles. We'll see that pizza slice come down there. Great. So the three angles equal 180, and they're a straight line, just like before. So we got to solve for the value of X. So 180 minus 66 minus 61. 53 degrees is what I've got. Now move all three vertices. So I'm not going to move them that much. Just, is that enough? Okay, I guess they want you to move them a certain amount. All right, now they want you to find the new value of X. So same thing, take 180, subtract 76, subtract 54. And that's 50. Just double checking. If the next problem is the same, I'm going to suggest we move to the other ones. All right, so this one is QRS. This one down here, I don't know, what color would you call that? Blue, green, gray?
Blue.
Blue. Okay, so that blue pizza slice comes up here. And again, it's alternate interior angles, QRS. They alternate over this transversal. So we're looking for the one that's RQT or TQR. Looks like it's that one. Alternate interior angles. So we should see that slice. Boom, there it is. All right, now RSQ, that is this 47. So that one's gonna come up here. So we're looking for UQS or SQU for the angle. SQU, and they're alternate interior angles. All right, and then the last one here is just like before, they add up to 180 and they form a straight line. So the value of X must be 180 minus 65 minus 47, so 68. Now we got to move the vertices till the thing changes. Okay. All right, so same thing. You subtract the 36 and the 58 from 180.
This looks so hard at first.
It's very repetitive, you know. I'm surprised that they're not changing it up. And I agree. It was I didn't really know what they were wanting at first. So, you know, to ask a student, you know, first time seeing it, it's going to be tough. All right, if this next one is the same, we can come back. This is the same. So I would recommend moving to the other sections, but that is up to you.
Yeah, we can.
Okay. All right, so this one says there's one missing step, which is interesting.
It looks confusing.
Say that one more time.
It looks confusing.
Yes. Let me see if I can frame this all on the screen here. Yeah, okay. So BD and AC bisect each other. So that means that AE is congruent to EC. That's the first part. The second part is that DE is congruent to EB. Okay. They're trying to help you here by like when you're hovering over like number 4, they're telling you that those angles are congruent. So that's good. What else? Side angles. Okay, so I'm trying to, I mean, I don't want to just give you the answer, but I'm also not sure how else to help here. So we know that AE is congruent to EC, and we're trying to prove that the triangles are congruent by side angles. Need another side congruent. That's the DE congruent to EB. So that should be on this list, which it's not. Why is XY on here? That would almost appear to be a mistake to me. Okay, so like what we need to do, and I guess we could go to a new problem. If I see solution, what will that do?
I don't know.
Okay, so here's what I'm trying to. We know for sure that DE and ED are congruent because the AC and BD bisect each other. And because it's a side angle side proof, we need to show that 2 sides are congruent and 1 angle is congruent. We have the angle, but this one has to be the other the other sides, and it's got all the wrong letters. So I would like to try this. Sorry, that's not what I want to do. Oh, okay, I get it. I'm sorry. Now I get it. You have to actually fill in. Now I get it. You have to fill in what's congruent. Okay, so DE is congruent to EB. Sorry for waffling there. I really just didn't know what it was going to do. The reason is the same reason as above. A segment bisector divides a segment into two congruent segments. Any questions on that?
No.
Okay. I'm happy to snip this into my other screen and kind of step you through it. I don't know how helpful that will be, but let's see if we got this one right. Great. Okay. So here's the triangle. And we're trying to prove that AC is perpendicular to BD. And that looks perpendicular, but we can't just say that, okay? So the given is that angle A, which I guess I can't, angle A and angle C are congruent. That's the given. It's also given that BD bisects triangle ABC. So since BD bisects angles ABC, that means that this angle up here and this angle up here are congruent. We also know that this angle down here and this angle down here are congruent. And then the next thing they tell you is that BD is congruent to BD. The angle is congruent to itself. So the two triangles are congruent by angle, angle, side. Okay, so we know that the left triangle is congruent to the right triangle based on this. All right, so now we can say that that's the one we're doing there. Okay, so here's what we can say. We can say that this side BD bisects AC. Because we know the two triangles are congruent, so we know that AD is congruent to DC. Okay, and segment, the segment bisector intersects the segment to form two congruent segments. Okay. Let me just try this. Hopefully this will take. Does not like that. Okay. So why can't we say that? Why can't we say that BD bisects AC? Two lines form linear pair of congruent angles, then the lines are perpendicular. All right. I wonder if it wants us to say that the angles are congruent, to say that angle BDA is congruent to BDC. It's a bit of a guess. It is true. And it kind of goes to the next one. They are a linear pair. So let's try that. Let's try BDA is congruent to BDC. And the reason is corresponding parts of congruent triangles are congruent. So let's try that. It's a bit of a guess here. It seemed to like that. Okay. So the idea is that since the triangles are congruent, you can say that the angle on the left equals the angle on the right, and therefore this bisects this down here.
Mhm.
I don't think that was a great explanation, but let's do at least one more problem here. Maybe this one will be more clear. Oh boy. Okay.
Mhm.
This is tough. Okay. Wow. Let's go back. Let's see if quadrilateral proofs are any better. Not really. Not really. Okay. All right, let's go back to the triangles. Just keep going here. All right, so I think one of the problems here is, and I don't know how helpful this will be if I zoom out. I don't know if that will be too difficult for you to see, but it might be necessary. So we're given that FA is perpendicular to DB. So that means that there's a 90-degree triangle, 90-degree angle here and here. FB is perpendicular to AC, 90-degree, 90-degree there. All right, and then we're saying, so that's what they go on to say here. They say that in a triangle, angles opposite of congruent sides are congruent. And then they tell you that the one we just mentioned is a right angle, and then same with the other, and then same with the, they say that the angle, even though like we know they're both 90, see how they're both 90, they go on to say that they are then congruent, and that because that one's congruent to itself, they can prove that the two triangles are congruent. Okay, so that allows you to say something, probably something about the angles. In a triangle, sides opposite of congruent angles are congruent. So we want to say that AD is congruent to BC. That's from the triangle. That's CPCTC. So let's try that. See if that works. Does not like it. Okay. What happens if we miss this a second time? Do you just take a new problem, or what's the penalty?
Yeah, they just give us a new problem.
All right. Let's go. I really, so if it's not those sides, maybe it's the DB congruent to CA. I'm reaching a little bit because these are really hard to follow.
This one's confusing.
Yes. DBCA. Did not like that. So what is the, wanted you to do the angle cab. That angle, oh, okay. Then you can say that those are congruent. I see. All right, well. So we'll do another problem here. Of course, it's not like it. All right. BE is congruent to BD. All right. AD is congruent to CE. And then angle, those are congruent because the sides are congruent. Okay, and then here they're saying that that's congruent to itself, AE is congruent to CD by, so they're sort of skipping steps, which maybe you can't see that, but there's a couple things in here that they're saying. So those are supplementary. Well, it's probably the case that the other grouping here are also supplementary. See how this one is around angle E? It's probably that this is also supplementary. So let's go that direction. And let's go EDB and CDB are supplementary. If two angles form a linear pair, then they are supplementary. So I guess they don't highlight it, but we're basically saying the same thing that's here in the picture on the bottom are now around angle D. Hopefully that's what it's looking for. There it is. All right, let's see what we got here. So it says that BCF is congruent to DCF. And then this line is congruent to this line. C is the midpoint of AE. So right in the middle here, C is the midpoint. So that means that AC is going to be congruent to CE. And that might be enough to prove the triangles are congruent. So our goal is to prove the triangles are congruent. And we know that we have an angle and then we have one of the sides. So we need the other side. We need to know that AC is congruent to CE, and that appears to be what's missing here. Now the reason. So see how it comes from this midpoint. C is the midpoint. Midpoint divides the segment into two congruent segments. See if that's correct here. And it is. Okay. All right, new problem here. So we're given that those two triangles are congruent. So that means that, and one thing I don't like here is I can't like hold on to it, but it's like AD is congruent to DB, AE is congruent to EB, or angles. You got all the angles and all the sides are congruent. Okay, so now they're using this part, AE congruent to EB. So that's a side. And then here's another side. Sorry, another side. So they're using side and side. Okay, we need the angle between them, which maybe is hard to see, but it looks like it's this angle here between them. So we'll just try it. And that's also from CP, CTC.
I never learned about the other ones like that. Oh wait.
Yeah, yeah. So there's like, it's like you guys are rushing through proofs. Normally, when you see proofs for the first time, they're around triangles, and you use this CP, CTC thing a lot. And it allows you to show that if the triangles are congruent, you can say that the side is congruent to the other side, this side is congruent to the other side, and so on. I don't know how helpful this is because I just feel like we're just guessing a little bit, but now we're getting it done. I know we're getting it done.
Yeah.
Was there something else that would help you, or is this all you've got for us to do today?
That's all I have.
Okay. Do you get time to work on this in class?
Yeah.
Okay. All right. So this one says that AC and BD bisect each other. Okay. So that means that AC and BD. So that means that like BE is the same as ED. AE is the same as EC. Is that okay?
Okay.
So that's what it means. That's where it goes. Okay, BE is congruent to ED, and AE is congruent to EC. And then now they're saying the angle between them is congruent. That's vertical angle. So you have enough now. You have a side, an angle, and a side. So we have enough to prove congruence. Okay. Which we're trying to prove that BC. Okay, so we want to say that triangle BEC is congruent to triangle DEA. And that's by side angle side, because we've got the sides, the angle, or another side, and then the angle between them.
Mm-hmm.
Okay. All right, so quadrilateral proofs. Yeah, they make it seem like one missing step, but boy, there's a lot there. Okay, so when you're proving triangles are congruent, you go down like the way to do these now that I'm seeing a few of them is you go look for side, like what are they using, which is side angle side. They have the sides, they have another side. So this one must be an angle because we're missing the angle. Okay. So we want to prove that triangle BAF is congruent to CED, and we're doing it through side angle side. So we know that AF down on the bottom there is congruent to DE, and we know that BA is congruent to CE. So we want the angle between those two sides. Okay, so it looks like we need. So I'm just looking at this one more time. Looks like we need to show that we already have that though. I was going to say angle A is congruent. Okay. So what I'm stumbling over here is I see that BA is congruent to CD and AF is congruent to DE, and this angle is already congruent to this angle. Which feels like it's enough to give that the triangles are congruent. Side, side, angle, side, side, angle, side. Oh, we don't have a reason though. Why are the angles congruent?
Mm-hmm.
All right, I'm a little stuck on this one. Let me I'm gonna just show the solution. Is that okay?
Mm-hmm.
Okay. Try to figure out what they want here. Okay, so they wanted the one that we did not put in here, FD congruent to FD. Why did they want that? I'm not sure. So they're saying here that they're subtracted from congruent segments. That's why they had to say that FD is congruent to itself. That's not helpful, but we'll look at another problem here. Okay, this thing is a parallelogram, so that means that opposite sides are congruent. Opposite sides are congruent. They're also parallel. They're giving you that BE is perpendicular to AC. So that's a 90-degree angle there and a 90-degree angle there. BC is congruent to AD. We just talked about that. BC is parallel to AD. We just talked about that. This is congruent by alternate interior angles. Okay, that's good. And now we get to where we don't know. We know that that's a right angle. We know that those angles are congruent. So it's almost like we have to say that the other one is a right angle. That see how it says DFA is a right angle, and then it like covers it up with the congruence. So it's like we need to go here and say that this one is a right angle as well. So let's try that. I guess not. Is that not an option? Oh, there it is. Okay. BEC is a right angle, and then perpendicular lines form right angles. So let's see if it takes that. There it did. Okay. So there it is. So that's a right angle. The other one's a right angle, and then they're congruent. These are actually much easier to do without all the information given. All right, ABCD is a rhombus. There's your rhombus. So in a rhombus, all the sides are congruent. So BC is congruent to AD, AB is congruent to DC, and you actually see that here, there, that the two sides are congruent. That's also given. So that's a different part. That's like of the triangle there. So one of the things, like when I see a CP CTC, I know that the previous line is a triangle congruence. Okay, so it looks like we're proving that this lower left triangle is the same as this one up here. So what do we have? We have an angle. That's good. We have a side and another side. So it looks like we're using side angle side, 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 angle. Where's the angle, angle side? Boy, these are confusing. Angle, angle. Okay. All right, so it looks like we're proving that AFD is congruent to EDC. No, AFD EDC. Okay, let's try that. Oh, goodness. Okay, why didn't it like that? I could have gotten the letters wrong too. FD. I did get the letters wrong. FD, AFD. All right, FA. I got those are wrong as well. FADE. I'm sorry. Yeah, these are just very awkward. I'm not even sure how to explain these. FA is congruent to DE. ADE. Okay. So FAD congruent to DEC. Okay, so that side, oh, it's going backwards. FA. FA to DE, AD. Why is it that way?
Are you muted?
No, I'm trying to not mess this one up, but I'm really struggling here because this one's rotated and flipped. And it's really hard to see. So we're just gonna see the solution here and see if there's a bad FAD. So I don't know if you can see it, but it's like A and A are there, but it's actually like if you imagine flipping your hand and then rotating it, because this 3 is actually over here. So it's like flipped and then rotated up. That's why it was so hard to see this. Let's see if we can get one more. I mean, they're not giving you any sort of like build up questions. They're just like, yep, here you go. Bad equals FDA. EBC equals ECB. So if they're parallel, that means an angle is congruent. So the parallel always leads to congruent angles. What angles would they want us to show are congruent? So this AD parallel to BC, it's cut by a transversal. So we're either showing that this angle up here is congruent to this angle down here, or this one here is congruent to this angle here. And so that's the big one with alternate interior angles. So you can find that. Okay. So the question though is which ones do they want? Parallelogram, that angle is congruent to that angle is congruent to that angle. So I guess they want this angle down here congruent to this one up here, just kind of following the sequence, like this angle, the one on the lower right equals the one on the bottom left. And I think that's why they want you to do that. Yeah, so we got to say that DAF is congruent to BCA. DAF is congruent to BCA. And you can choose any point on the line there. Open. Here's hoping. There it is. Okay. If you want, we could spend the last 2 minutes working on the sum of triangle angle proofs, or we can stop here. So these are again, like it's KLM. So it's like first the one or the other equals down here, this piece. So That's NKL or LKN, LKN, and that's alternate interior angles. You'll see that one slides right in there. Boom, got it. LMK, LMK here, this other one, it goes down here. OKM or MKO, and that's alternate interior angles. We'll see that that flops right in there. They add up to 180 because they form a straight line. And the value of X you subtract from 180. So 180 minus 39 minus 58, 83. And then they want you to move the vertices. So you have to move them a little bit till that dot changes colors. And then you do the same thing. You subtract those two angles from 180. So 82 this time. All right. Well, it's over. I would get as much help as I could on the quadrilateral proofs. Those are
Mhm.
obviously the most difficult.